Welcome to Uncut, Gems and Their Stories. I'm Paige. How are you? Whether you're here to unwind, learn something new, or just escape reality for a little while, you're in the right place. Because this is the podcast where we dig into the raw, unpolished stories hidden inside the world's most incredible gemstones. So grab a drink, light one up, get comfortable, and let's uncover another story. Welcome to Uncut. Welcome to the first rebranded episode of Uncut with Paige. We will always be stoned stories, okay? And we know that. But from now on, we're going to be a little more polished, put less emphasis on the stoned part of the stories, and more emphasis on the stone of the stories. Okay, now, other than that, same content, same host, same vibe. So, what if I told you that every once in a while, the earth sends us a message, not in words, but by accidentally spitting out tiny pieces of itself, pieces that were never supposed to see daylight. Imagine holding a rock that spent millions of years beneath your feet, a rock that was over 60 miles beneath our footsteps, a rock that formed in complete darkness under pressure much stronger than what humans are capable of recreating for long periods of time at all. A rock older than mountains, older than continents, older than almost everything you've ever touched. And that is what a xenolith is. Today we're going to talk about why these forgotten little rocks completely changed how we understand our planet. Why they quietly tell us that Earth isn't just a giant floating rock, it's a living system. And why some of humanity's favorite gemstones begin with their journey in these hidden places deep below us. This episode is inspired by a friend of mine. She recently brought me a xenolith, and since she put this piece of earth in my hand, that she found herself hiking among these beautiful volcanoes, the whole picturesque story, the way that this piece of earth was put into my hand as a gift from this amazing woman on this amazing journey, let's just say, I have gone from not being able to pronounce the word xenolith to obsessing over the geological timeline of its formation. So this episode is going to be a little nerdier than usual. And we're going to deep dive all the way into Earth's mantle. When we think about Earth, it's easy to imagine it as solid, stable, permanent. Well, we hope so. We build cities on it, drive across it, plant food in it, and it feels unmoving. But that's only because our lives are incredibly short. If you could speed up time, the continents would drift apart like giant rafts. Mountains would rise, oceans would disappear, new islands would erupt from the sea, and old crust would sink back into the mantle. Earth is constantly rebuilding itself, not over years or centuries, but millions of years. It's less like a rock and more like a living organism with an incredibly slow heartbeat. Its crust breaks apart, its mantle slowly circulates, and its core generates a magnetic field that protects every living thing from solar radiation. Nothing is static. Everything is moving. Even though we rarely notice it, geologists often compare Earth to a recycling machine. Nothing really disappears. Old ocean floor gets dragged back into the mantle, continents collide, volcanoes return material to the surface, and even the carbon that becomes life eventually finds its way back into Earth's interior before beginning the cycle again. Earth has been recycling itself for over 4 billion years, and yet there's one enormous problem. We've never actually seen most of it. Humans have explored space, we've walked on the moon, sent spacecraft beyond Pluto, but the deepest hole we've ever drilled into Earth was only about 7.5 miles. That's called the Kola Superdeep Borehole. Located in Kola Peninsula in Russia, this 40,230-foot deep hole was first drilled starting in 1970, and drilling continued until 1994. The whole point was to understand our Earth's geology. And at its deepest point, temperatures reached 356 degrees Fahrenheit. That was way hotter than expected, and it led to the project's eventual abandonment. They just didn't know how to get deeper, and it sounds impressive until you realize Earth's crust alone can be over 18.5 miles thick, so we didn't even get halfway. The mantle begins beneath that, and the center of the Earth sits almost 3,900 miles below us. We've never been there. We've never directly sampled it. So how do scientists know what's down there? Partly from earthquakes and partly from physics, but partly from rocks that the Earth accidentally delivered to us. Those rocks are xenoliths. And the word comes from Greek. Xeno means foreign and lith means stone, a foreign stone. A xenolith is simply a piece of older rock that becomes trapped inside another rock, usually molten magma, as that magma rises toward the surface. So imagine lava rising through Earth's crust. It's hot enough to rip pieces of the walls of the underground rock as it passes through. But that underground rock is meant to be heated at really high temperatures, so the magma doesn't even melt it. Instead of melting those fragments completely, it carries some of them upward like passengers on an elevator. Eventually, the volcano erupts, the lava cools, and suddenly, a rock that spent millions of years deep inside the Earth is sitting on the surface. It's almost like finding a page that fell out of a book no one has ever been allowed to read. Many originate from the upper mantle, roughly 12 to 24 miles beneath us, and are rich in magnesium and iron-bearing minerals like olivine and pyroxene. They are literal samples of Earth's hidden interior. Remember, xenoliths can be formed in non-igneous or volcanic rock. So let's just touch on that for a second, because at first I could picture the idea of these xenoliths getting ripped up through volcanoes. But I couldn't understand, how else are we finding xenoliths? That has to be the only way, but it's not. You see, sometimes it's just much less dramatic. Imagine an old mountain slowly being worn away by rain, wind, and rivers, and pieces of that mountain break off, get carried downstream, and eventually settle into layers of sand and mud. Over millions of years, those sediments harden into new rock, and older fragments are now locked into something younger. That's still a xenolith. They just got there through erosion instead of magma. And even space has its own version. Some meteorites contain xenoliths that were broken off from larger parent bodies earlier in our solar system's history. Wow! Those ancient objects collide, fragments become trapped inside newer rock before eventually falling to Earth. So whether they're carried by lava, washed into sediment, or launched through space as ancient planetary pieces, the idea is always the same. A xenolith is a piece of an older story, preserved inside a newer one. Today we're talking about the kind that completely changed geology, the ones volcanoes deliver from Earth's hidden mantle. Because those aren't just foreign rocks, they're pieces of our world we were never supposed to see. And one of the best places on Earth to find mantle xenoliths is actually where I've been living the last few years, the big island of Hawaii. Hawaii is made up of 5 volcanoes, and they're shield volcanoes rather than a strata per se. A stratovolcano is typically very point-shaped, very triangular, and oftentimes sitting on a fault line or area of high seismic activity. Think the Pacific Ring of Fire. When the tectonic plates shift, there is a tumultuous energy release, and you can have earthquakes and volcanic eruptions, and it's much less predictable than a shield volcano. A shield volcano, it sits above a hot spot, a spot in Earth's crust that stays in one place while the crust itself moves. And this hot spot is a direct hole or drill, down into Earth's mantle, consistently releasing magma, energy, heat, and pressure, rather than waiting for a slippage or an unpredictable moment of tension release like a stratovolcano. So let's bring it back to Hawaii. Hawaii is made up of shield volcanoes. It's what created the islands, and it's what the islands are made of. Now, there are 5 volcanoes, like I mentioned: Hualalai, Mauna Kea, Mauna Loa, Kilauea, and Kohala. And living on the Big Island, it was a pretty big deal to me to remember which volcano is which, how to pronounce their names, and something about each one. And I only memorize things in story form. It's what I do. It's who I am. So I had to create a little story to help me memorize what volcanoes I was looking at and essentially help me navigate around the island. This is what I came up with, okay? So the goddess of lava, Pele, is a woman. She's strong. She's independent. So essentially, all the volcanoes, in my mind, had to be strong, independent women. And I needed them to each have a personality, or at least a piece of their personality that helped signify which was which. So we're going to start at the youngest. The youngest volcano is obviously Kilauea, the most active volcano in the world for much of its recorded history. And, it's always throwing a fit. It's always crying. Everyone comes to the island to see the national park where Kilauea sits in the middle, and it's just naturally the baby sister of the family. Then I thought, who is the middle child? And it's a volcano that is always the hardest for me to remember the name of. It feels like it's the one talked about the least. And yet, it's the volcano that at least I am living on in Kona. There's so much going on in the volcano. It's technically still active, and yet no one pays attention to it. It just feels like the glue of the island, and that is Hualalai. And then we move to the biggest volcano, the largest active volcano in the world. Very obviously to me, that's got to be Big Sister. So Mauna Loa, that's the big sister in the way that I remember the volcanoes. And it's the biggest, like I said, volcano not only on the island, taking up a third of Hawaii, but it's the largest in diameter active volcano in the world. It's a pretty big deal. We've already got 2 records on the island, most active and largest. Then that's 3 of the 5. So it takes me to the last 2 volcanoes, and they both felt a little bit more matriarchal to me. So Mauna Kea is the tallest mountain in the world, measured from the seafloor. From the ocean, it's, under 14,000 feet, but barely. And it looks over the rest of the island as a mother would look over the rest of, her children. And so Mama Mauna Kea is just sitting. And lastly, but not least, Kohala. Kohala is the farthest away from Kilauea, and it's this old volcano that's extinct. It's pretty grown over because it's had some time to decompose, and so it has this kind of wispy green to it. And it's set up looking over the channel between Maui and the Big Island, where the humpback whales often come in the winter. It just feels like Kohala is in her retirement age, and she's doing her thing, resting, watching the whales. She gives grandma energy. So this is how I remembered the volcanoes of Hawaii. And recently, I've learned something that really stood to Hualalai's middle child energy. And that is that she has produced the most xenolith out of the volcanoes on Hawaii, and one of the most popular xenolith producing volcano in the world, mostly because of Hawaii's shield volcano rather than being a strata, but also because these volcanoes have a very deep hole into the mantle, and there's a lot of peridot present on the island. It's iron rich. It's the perfect ingredients to create these xenoliths. And more than the other volcanoes, Hualalai has several eruption zones where scientists and hikers alike have found xenoliths in its old flows. Wow. Okay. So now I need to talk to you about one eruption that is especially famous, and it's 1801 Kuapu'alehu lava flow on Hualalai. This eruption scattered countless ultramafic xenoliths across the landscape, rounded nodules wrapped in paper-thin coating of lava. Remember, this is pieces of mantle being ripped up in a flow. The flow had very high viscosity, which means the magma was flowing more like water than it was like honey. And so just barely wrapping these mantle chunks in lava, the eruption scattered all of these around the flow. And scientists believe many of these rocks crystallized between 10 to 13 miles below the surface before they rode upward. So now imagine that. One volcanic eruption acting like an elevator, bringing pieces of Earth's mantle directly into human hands. Without volcanoes, we would probably never know what these depths actually look like. This is where gemstone lovers should start paying attention. I mentioned peridot because xenoliths don't just carry ordinary rocks, they can sometimes carry treasure. It's how you know a xenolith is a xenolith rather than another piece of lava rock. Mantle xenoliths commonly contain minerals like olivine, garnet, and pyroxene, some cases diamonds. not in Hawaii. But these minerals didn't form near the surface. They grew under crushing pressure. Well, condensation was trapped in Earth's crust, or maybe when rocks within Earth's core were reheated and melted before being shot upward in rising magma, over unimaginable spans of time, long before humans existed. Many gemstones owe their beauty to conditions that only exist deep inside a planet that's constantly changing. They're born because Earth is active, because continents move, because magma rises, because pressure transforms ordinary minerals into extraordinary crystals. Without a living Earth, many of the world's most famous gemstones simply wouldn't exist. And as I was researching this and getting down the rabbit hole of how we have so few ways to understand what's actually going on in the core of our planet, how these pieces of rock are some of the only clues given to the story of the geology below our feet, it also made me wonder if this is why gemstones have fascinated humans for thousands of years. Not because they're expensive or shiny, but because we realized it, or maybe we didn't, but they've always been this tiny piece of a story much bigger than ourselves. They're this piece of the earth that, we can wear on our fingers or around our necks, but they're also an example of this living experience that we're in, our bodies are connected to, and they're evidence that the ground beneath us isn't dead. It's moving, breathing in geological time, recycling itself, creating new worlds while slowly destroying old ones. Once again, a lesson that we can take from the world around us. And every once in a while, our world gives us a glimpse beneath the surface, a chance to hold the product of that internal movement, a little reminder that we've only scratched the skin of the planet we call home. After diving deep into xenoliths and continental shifting and the impact of geological time, I may be left with more questions than I had before this episode. And I'm not sure if I'll ever be able to comprehend the depths to reach Earth's core, or the span of time it takes for a xenolith to reach Earth's surface. Yet somehow, without fully grasping the weight of our planet's size and age, holding a gemstone in my hand, seeing a stone on someone's finger, or gazing at a giant geode behind museum glass, all leave me with the same comforting sense. A physical example of Earth's slow-moving changes and the proof of life behind our planet. And a little proof behind the pudding of how important recycling it within ourselves is. Beautiful things come of using what's already there, reshaping them, staying strong under pressure, and emerging as a completely new gem. That's all for today's story. Thanks for tuning in. Don't forget about next episode. This upcoming Friday is obsidian, another incredible volcanic stone. And, well, let's face it, next episode, it's also sure to be a gem.